All right, we are back with day 2 of solving quadratic equations. We are going to start off with a quick little recap solving using each stated method. So the first one we are being asked to use is factoring. Before I can set up my x, I am going to need to move over both of these things on my right-hand side. So I now have 5x squared plus 7x minus 6 equals 0. So setting up my x, 5 times negative 6 is negative 30. My middle term is 7. Magic numbers that multiply to negative 30 and add to positive 7 are 10 and negative 3. I am going to need to divide both of those by a since it's not 1. 10 divided by 5 is going to be 2. Negative 3 will not evenly divide, so at the moment I've got x plus 2 and x minus 3/5. I'm not done yet though. I still need to clear this denominator. So I'm going to multiply both of them by 5, so I've got 5x minus 3. And x plus 2 are my two factors. So then to solve, I'm going to set both of those equal to 0. On the first one, I just have to subtract 2, so negative 2 is my first solution. On the second one, I need to add 3 and then divide by 5. So my second solution is 3/5. Okay. Moving on to the next one, we are being asked to use quadratic formula. So what I'm going to do is move over that 171 so everything is on the same side. Okay, and then before I set up my formula, 342 and 171, believe it or not, if you add up the digits and it's divisible by 3, that means that that number is divisible by 3. These all have a common factor of 3. So if I factor that out, I would have x squared plus 14x plus 57. So I'm going to use those values for my A, B, and C so that I'm working with smaller numbers here. So x is going to equal to negative 14 plus or minus the square root of 14 squared minus 4 times 1 times 57, all divided by 2 times 1. So moving up here, I've got negative 14 plus or minus 14 squared is 196. Negative 4 times 1 times 57 is negative 228, all divided by 2. 196 minus 228 is negative 32. So this is going to be an imaginary solution, and it's not a perfect square, but I can rewrite this as negative 14 plus or minus. That is going to give us 4 square root of 2i over 2. And now negative 14, 4, and 2 are all divisible by 2, so I can go a little bit further and get negative 7 plus or minus 2 square root of 2i. So what that means is my two solutions are negative 7 plus 2 square root of 2i and negative 7 minus 2 square root of 2. Okay, now we are looking at the square root method. My squared binomial is already alone, so I can square root both sides. On the left, I'll have x minus 2, and then this is going to be plus or minus 48. It's not a perfect square, but it does have a factor that is. That's 16 and 3. So I can bring out the square root of 16, which is 4, and then 3 is still inside my radical. X is not alone yet. I need to add 2. So my two solutions are going to be 2 plus 4 square root of 2 and 2 minus 4 square root of 2. And then I forgot to box in my answers for the previous one. Okay, last one, completing the square. In order to complete the square, I first need to move that constant over. So I'm going to move the 27 to the other side, so it's now negative. And then to figure out what completes my square, I need to half the middle term. My middle term is 12. Half of that is 6, and then I need to square it. Well, 6 squared is 36, so I need to add that to both sides. So this factors to x plus 6 squared, and that's going to be equal to negative 27 plus 36 is 9. So now I can square root both sides, and I get that x plus 6 is plus or minus 3. Subtract the 6 to get x alone. And these are both whole numbers, so I need to actually do these operations. That's going to be negative 6 minus 3 or negative 6 plus 3. So negative 6 minus 3 is negative 9. Negative 6 plus 3 is negative 3. And there we go. There is our recap from last time. We are going to now look at solving by completing the square, but when a is not 1. There is an extra step we have to do. So it starts out the same as it would normally. You're going to move your constant to the other side, and then this is where your extra step comes in. You need to divide everything in your equation by whatever a is, that leading coefficient. Okay, so sometimes that is going to cause you to be working with fractions, but we did that a lot last time, so there's nothing to worry about there. After you divide everything, you're going to figure out what completes your square, add that to both sides, rewrite it in completed square form, do your square root method, and simplify. Okay, so let's jump straight into some examples here. On example 2a, I am going to move over the 1. So it's now negative. And my a value is 3. So I need to divide everything by 3. So that means on the left, I will now have x squared minus 2x equals negative 1/3. Now, I was lucky here this stayed an even number, so half of negative 2 is negative 1. Negative 1 squared is positive 1, so I need to add positive 1 to both sides. So this is now going to be x minus 1 squared equals, this is just some simple fraction addition. Rewrite 1 as 3 over 3. Negative 1/3 plus 3 over 3 is 2/3. So now I can square root both sides. And this is not going to be anything pretty, but x minus 1 is going to be plus or minus the square root of 2/3. Now I need to move 1 to the other side. So I'm going to have 1 plus the square root of 2/3 and 1 minus the square root of 2/3 as my two solutions. Okay, moving on to b, we are going to be following those same steps. First, I need to add 8 to the other side. And now I need to divide everything by a, which is 2. So I'm going to have x squared plus 5 over 2x equals 4. Now I do have a fraction here, but that's nothing to freak out about. Half of 5 over 2, if I am dividing that by 2, recall that that's like dividing by 2 over 1. And if I'm going to divide fractions, we would keep, change, flip. So this is 5 over 4 is half of my middle term. So if I want to square 5 over 4, that's going to give me 25 over 16. So we're adding 25 over 16 to both sides. So this now becomes x plus 5/4 squared. And that is going to be equal to, I need to do some fraction conversion here. I need a common denominator of 16. 4 times 16 is 64. So 64 sixteenths plus 25 sixteenths gives me 41 sixteenths. So now I can square root both sides, and I have x plus 5/4 is going to be equal to plus or minus. Now 41 is not a perfect square, and in fact it's a prime number, but 16 is a perfect square, so I can simplify my denominator. And then the last thing I need to do is subtract that 5/4. So x is going to be negative 5/4 plus the square root of 41 over 4, or negative 5/4 minus the square root of 41 over 4. Okay, 2 more examples to go. On to C. I need to rearrange this a little bit. I need to move the 24x over to the other side, and I need to subtract the 42 to get my constant out of the way. So I have 3x squared plus 24x equals negative 42. And now a is 3, so I need to divide everything by 3. So x squared plus 8x is going to be equal to negative 16. So what's going to complete this square? Well, half of 8 is 4. 4 squared is 16, so I need to add 16 to both sides. So x plus 4 squared is equal to 0. All right, so I can square root both sides, and I get that x plus 4 is going to be plus or minus. 0 is a perfect square, believe it or not. The square root of 0 is 0. So x is still not alone quite yet. I need to subtract the 4. So x equals negative 4 plus 0 or negative 4 minus 0. So this is one of those situations where we get a repeated solution, right? Because adding or subtracting 0 does not change your answer, and we get negative 4 and -4. Okay, one more for the road, moving over that constant 100, and then dividing everything by a, which is 5. So x squared plus 12x equals -20. What is going to complete this square? Half of 12 is 6. 6 squared is 36. So x plus 6 squared equals -20 plus 36 is 16. Square root both sides, and x plus 6 is going to be plus or minus 4. So now I can subtract 6, and we will have -6 plus 4, or -6 minus 4. Those are whole numbers, so I can actually do those operations. -6 plus 4 is -2. -6 minus 4 is -10. And there are my two solutions. Okay, I'm running low on time, so I'm going to record the rest of this in a second part.